This is Mrs. O'Neill for AP Chemistry, Chapter 4, Section 2, Precipitation Reactions. You should have watched that intro lesson on molecular ion and net ionic equations. Here are my notes, but I am going to go through these rather quickly because you should have learned this stuff in Chem 1. So this should be review. So when you observe something, you should be able to figure out what those chemicals involved in the reaction are. Gave you a nice flow chart as he always does. He also did a thet.colorado.edu simulation where he tried to explain to you or show you visually how you can only change those coefficients. You cannot change the elements or the compounds formulas within them. So he talked about the 4 steps of observing something, describing what happens, writing those reactants and products, and the states of matter, which are going to be really important when we do the net ionic equation, and of course balance. So an aqueous solution is just something that is dissolved usually in a solvent such as water. So the molecular reaction is what you are used to seeing in Chem 1. The ionic equation is taking that molecular equation and busting apart in all those ions with the exception of that solid precipitate that forms. Notice that solid stays a solid all the way through. And of course the net ionic equation is the important reaction. What's really happening? Because we can cancel out all of these spectator ions. I'd like to give you an analogy of a spectator ion is like spectators at a sporting event or a spectator at, let's say, a cheerleading competition, or let's say you're spectating a concert, a musical concert, or even a Broadway play, right? You're spectating, you're just watching the show. But the real important stuff that's going on are the football players, the cheerleaders, the musicians, or the actors and actresses. Okay, that's really the net ionic equation. So here are all the species in solution. That's called the ionic equation or the complete ionic equation. That's what we're going to call it. And of course, the only reaction that's really occurring is the net ionic equation. That's what the chemists are really interested in. So on to your packets of notes. Your objective for this section is to identify reactions in which soluble reactants yield an insoluble product. So soluble means aqueous, right? It dissolved, and insoluble would be that precipitate that forms. So I thought this was interesting how it talks about carbon dioxide converts calcium hydrogen carbonate into calcium carbonate. The calcium carbonate precipitates and forms these beautiful stalactites and stalagmites. So I thought that was pretty neat about caves. So pause the video, fill in your blanks, and then play to hear my words. So a precipitation reaction is also known as a double displacement reaction or exchange or metathesis. So those are just different terminologies meaning the whole same thing. So aqueous solutions of ionic compounds pouring together, and usually, not always, a solid forms. And that solid that forms is called a precipitate, or I like to abbreviate as PPT. And it's that insoluble solid that is formed. If you are not part of the solution, you are part of the precipitate. So let's review double displacement. You should know how to do your outers and inners. I just want to make sure you're understanding that because the C here is a positive ion, the C as your product also has to be a positive ion. So my steps are inners and outers, or outers and inners. Positive, negative, make sure that your compounds always start with a positive ion and end in the negative ion. Crisscross those charges if you have to. Find that precipitate, and we're going to talk about that in a moment. And of course, then balance the overall reaction. So here's a nice visual for you, taking potassium iodide, which is a nice clear solution, taking your lead 2 nitrate, which is a nice clear solution. But when you pour them together, you get this yellow solid, or this precipitate of lead 2 iodine, which is the paint on your roads, by the way. And you have these spectator ions in the solution of potassium nitrate. So again, if you are not part of the precipitate, you are part of the solution, or vice versa. So how do we know which product is the solid precipitate that formed? Well, it's based off of solubility. And solubility is how much substance can we dissolve in a certain amount of water. And usually it's how many grams of that salt can be dissolved in 100 milliliters of water. And you're going to soon see a chart in the upcoming chapters of solubility, because it has to be found experimentally in this huge chart of how many grams can be dissolved in milliliters according to temperature. So we'll talk about that later. So that's why it says here it varies greatly, especially according to temperature. So if a substance dissolves, the ions are separated, and of course those ions move around. So in your book on page 121, there are solubility rules. Please do not memorize them. I give you a little generalization in your packet, as well as charts to look at. And I'm also going to put something on the wall called solubility tricks. So we'll get there. But if you ever see a chart like this, what does this mean? Well, let's look at aluminum bromide. Aluminum bromide has an S, and on the bottom here it says soluble. That means if aluminum bromide is one of your products, it would be soluble, it would dissolve. That would be the AQ next to that formula. However, if you have aluminum hydroxide, now you have an I. That means it's insoluble. Bada bada bing, that's your precipitate. That would get the little S next to that formula because that's the solid that formed. So here are those general rules of solubility that are also on your packet. Just some things to note. 1 and 2 are all. 3 and 4 are soluble with some exceptions. And number 5 and 6 are insoluble with some exceptions. So just kind of look those over. And again, you'll have that at your disposal to use with your practice problems, your book problems, and things of that nature. So here are some solubility tricks that I will put on around the room. So sag, nag. Whenever you sag your pants, someone is going to nag you. So again, if you have a compound with sulfate, those should be soluble. If you have a compound with group 17 ions, those will be soluble, and so on. However, just like everything else, there's always exceptions to the rules. So almost all sulfates are soluble. Almost all group 17 are soluble, except if they are with elements PMS, lead, mercury, silver. Also, sulfates are insoluble, never are soluble when they are with calcium, strontium, or barium. So in other words, if your product is calcium sulfate, it would not be soluble. That would be your precipitate. So again, we'll talk about this. You'll do some practice problems, and hopefully you'll catch on to what these tricks really mean. So here's an example 1. As far as all we're doing right now is your outers and inners, forming your new compounds, and seeing if you can use either the chart in your book, the general guidelines that I just gave you, or those solubility tricks, and finding that precipitate. Should have gotten that. Now balance. Should have gotten that. And again, if they are having trouble, we have a couple more examples here to figure that out, or you could also see me in class when we're doing our book work. Example 2, again, do your outers and inners, form your correct products, and find that precipitate. Should have gotten that. Now balance. Should have gotten that. Okay, practice problems, definitely pause the video at this point, do your outers and inners, find the precipitate, and then balance that reactions. And here are your answers. Again, if you have questions, please come see me. So why is this so important? Because what is really happening in a precipitation reaction? Well, here's our reaction. Here's our precipitation reaction. We got some sodium hydroxide, some iron 3 chloride, and our products, our outers and inners, crisscross those charges, and we get sodium chloride and iron hydroxide. Our iron 3 hydroxide here is really what's going to be important, because that's the precipitate. That's what's really coming together. So we got to split everything apart into a complete ionic equation. Hopefully you see that the 3Na plus comes from that coefficient. The 3OH minus comes from that coefficient. There's 1 iron plus 3 ion, but there's 3 chloride ions. So again, if you're having trouble figuring that out, maybe pause the video and make sure you know where all of those coefficients are coming from. So what really is happening, the important part of the reaction, is those hydroxide ions and the iron 3 ions are coming together to form that precipitate. So there are three basic equations. There's a molecular equation, there's the complete ionic, there's the net ionic. So the molecular is what you're used to seeing. The complete ionic is busting everything apart. Those spectator ions have to be canceled because they are on both sides. They don't react. Remember, they're just spectating. They're just looking around. And of course, that net ionic equation is the important one. So my analogy to you is the complete ionic is like your gross pay. It's your full salary, how much you get no matter what. However, your net ionic is the important one because that's the actual amount of money you have to spend and how to budget with. So let's look at this example as far as the three different kinds of reactions. So your molecular equation is what you're used to, but the complete ionic. So we're going to bust this guy apart. We're going to bust him apart. We're going to keep him the same, keep him whole because he's the solid precipitate, and we're going to bust him apart. So again, if you need to pause the video, make sure you're understanding where those two K plus ions are coming from. Only one CrO4 negative 2 ion, one Ba plus 2, two NO3 negative ions, and so on. So make sure that you're understanding where all those coefficients are coming from. So now we have to get rid of those spectator ions. The ions that happen on both sides, cancel those out, and there's our net ionic. That's the important reaction that's going on here. So example 2, see if you can go through all three. If not, again, kind of play and pause, going through the example. All right, you should have gotten that overall, so hopefully you can get that. So give it some thought. Again, what are those spectator ions? There you go. So my steps for writing net ionic equations are make sure to do your outers and inners and check for that precipitate. Balance that reaction, because if you don't have it balanced in the beginning, it's going to be really difficult or not correct at the end with their net ionic equation. Rewrite the equation to show the ions. Number 4, identify and cancel out those spectator ions, and then write the net ionic equation. We want to remember also that water will not break apart because it's a liquid. We also want to remember that if your reactant is a solid or if your reactant is a weak substance like a weak acid, it will break apart to make your products. However, they will stay together in all the equations. Same thing with your products. If your products are a solid, liquid, or a gas, they will stay together in all those equations. So I have some examples for you as well. So let's look at these practice problems. So again, I'm going to kind of click through, maybe make a couple of notations, but try them now on your own. Again, most of this is review of Chem 1 anyways. So here's number 1. Your molecular balanced equation should look like this. You should have been able to do your outers and inners. You should have been crisscrossing your charges, and you should find that precipitate. Now do the complete ionic, separating everything out except for that solid copper 2 sulfide. Cancel out your spectator ions, and there's your net ionic equation. Answer 2, similar. And there's your answer. Now 3 is a little different. Why? Well, let's look. That acid is weak. So when you're complete ionic, it stays whole. It stays the same because it is weak. And there's your net ionic. So notice, again, your weak substance stays weak, stays that same thing all the way through. It breaks apart to make your compounds, but it stays whole all the way through. Number 4. Again, you have that solid. Number 5. Again, you have that solid all the way through. Okay, take a moment to take this quickie quiz. So again, read over, pause the video, see if you can get the correct letter. Hopefully you got that. Probably took a little bit of time, but take your time. Make sure you know how to do these things. Number 2, look at that chart. Did you get that for an answer? Number 3, again, take the time to do all 4. Use your chart and get your answer. Okay, see you in class.